All right, we're solving exponential equations using a logarithm properties. So, first of all, a very basic equation. 8x is equal to 21. And again, remember the whole reasons for logs is that we can use the log, using logs here is that we can use the log properties, and then the x will go out in front using the property of log. So if I take the natural log on both sides, and again, it doesn't matter if it's natural log or common log, it'll both be the same. This then can come out front. So now I've got x times natural log of 8 is equal to the natural log of 21. And then, now remember, natural log, is a number. It's an operation on a number. So natural log of 8 is a number, much like the square root of 5 is a number. You can't just get rid of square roots indiscriminately. So we're going to go through and divide through by this. We're going to go divide through by natural log of 8. And then you've got x equals natural log of 21 over the natural log of 8. And then you can punch that in a calculator. Pull that up. When you're doing this on your calculator, please remember to, this is not the smoothest thing, my apologies. When you punch all this stuff in your calculator, what you want to do is make sure you close off parentheses as you need to. So you've got natural log of 21, close your parentheses. Otherwise, you're taking the natural log of a natural log, which can get really obviously wrong, and then the natural log of 8. So your answer here is going to be 1.4641. So this is going to be 1.4641. And actually, to be proper, let's say this is approximately equal to, because this right here is your exact answer. And this right over here is your estimate, or approximate answer. Okay, so depending upon what you see on tests, please make sure that you obviously give what they ask for. So exact, you're leaving everything in natural logs, and if they give you an estimate or they say round to the nearest 2 digits or whatever, 4 digits in this case, you can do that one. Another example, now if you've got logs on both sides, these can be a little messier, potentially because you're going to have to do some distributing and some factoring to make it work. So again, here, just again, no reason for it. Remember, you can use log or natural log. Either way is fine. There is no necessarily benefit of using either one unless you've got a base 10, in which case common logs can save you a little bit of time, or if it's base E, in which case the natural logs can save you some time. So just for sake of equality, let's use logs. Again, property of logarithms, this is going to come up front. So is this x. Now make sure you put parentheses around this because that's going to help remind you that you're going to have to distribute this log of 4, in this case, to both the 2x and the minus 1. You don't necessarily have to do that unless, like if I didn't have this x here, then I could just divide through by log of 4. Since I have the x here, I'm going to have to distribute this so I can get all the terms with x's on one side and everything without x's on the other. So now we'll distribute this to each part here. And again, have the log be the trailing part. So I'm going to have 2x times log of 4 minus log of 4 is equal to x times log of 7. Okay. We need to move all the x's on one side, everything else on the other. So again, what we're going to do here, I use the word again a lot, my apologies. We're going to subtract off that, and we're going to add in log of 4 to both sides. So then in this case, I've got 2x log of 4 minus x log of 7 is equal to log of 4. Now you may be asking, why didn't I just move this term here to the other side? Couple reasons. Partly because I've got this negative out here in front of the log, which I suppose it wouldn't have been that big of a deal. But sometimes those things can get messy, and oftentimes people will forget that. Either way, you're going to have to end up factoring out this log here. Pop this down a notch. So this x right here we're going to factor out, and get x there, The leftovers are the 2x log 4. Now again, do not be tempted to factor out just the word log. You can't do that. Log is, again, as I've said many times, it's an operation. It is not something you can just mess with. Except that Mr. Hayes miswrote this now. Nicely done, sir. All right, so let's fix this. 4, and then there's a 2 here. Okay. Divide both sides through by this whole entire number, so the 2 log 4 minus log 7. And all of this by 2 log 4 minus log 7. So then x is going to equal the log of 4 divided by 2 log of 4 minus log 7. Again, exact answer here. Approximate answer. Pull up your calculator. Yeah, well, there we go. You can do this a variety of different ways. If you're going to try to do this all in one shot, be careful. Make sure you put this entire denominator, the whole numerator and the entire denominator in its own set of parentheses. Since this is a single term, I do not have to put that in a set of parentheses. But particularly since I've got this part with more than one term down here, you need to make sure you put parentheses around the whole thing so it does all of this math first. So 2 times log of 4 minus log of 7, and 2 sets of parentheses to close it, and then I get an approximate answer of 1.7669, or excuse me, 1.6769, and again, that's an approximate answer. So there you go, 2 examples of solving logs. That should hopefully get you to where you need to be. As always, email, text, call if you have any questions. Thanks.